Let's begin. Today is November 25th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 6, 16, 19, 21, and 22. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in our grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, and the Turing Machine will compare it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our 3-digit solution and will let us know a little bit about the ratio of even to odds. Should the solution have more even than odds, or should the solution have less even than odds? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the value of the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. The first is where the solution does have a pair, as in the example 131, or alternatively, the solution has no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F will take a look at our 3 digits, triangle from triangle to square to circle, and will let us know a little bit about the order of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, or could they appear in a descending order, or basically be decreasing, as in the example 421, or could it be that the solution has no order? So let's take a look at the example 231. Notice that it goes from 2 to 3, it increases, and then it goes from 3 to 1, then decreases. Of course, you could also have a solution that is decreasing and then increasing, but it's that shift from one direction to the other that defines a 3-digit code as having no order. Now, we have seen in other puzzles where if you have consecutive equal digits, that can also exhibit no order. So, for example, if you had a code that would say 225, when you go from the first 2 to the second 2, it neither increases nor decreases. So the fact that it doesn't exhibit an increase or decrease is another way to define that a 3-digit code has no order, because of course increasing or descending and ascending are strictly decreasing and increasing. And if that's not achieved throughout the 3 digits, that exhibits no order. And remember, the objective of today's puzzle is to find that 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice. I did pick an odd 1 for my square digit, but since the Turing Machine does not agree with that, it's letting us know that square should actually be even. So let's go ahead and type that up in our notes in section B. And we'll say that square is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds, 1, 3, and 5. Now, we do have criteria card D, where we have the sum of the first 2 digits. Luckily, we've already established square to be even. So if it is to be equal to 6, that would mean that the other digit would have to be the other even. Now, unfortunately, my proposal has 3, 1. So obviously, if I get an X, it doesn't necessarily establish that it is equal to 6, but at least we'd be eliminating one of the possibilities. So let's go ahead and test criteria card D. Well, you know what? Give me 1 second. Actually, let's do this. Let's actually test criteria card C first, because if we can establish that there's a majority of evens, that may be a better, criteria card D may be a better third test. So let's actually test criteria card C first. Okay, so it approves of my proposal of 314. Now notice that criteria card C is looking for the ratio of even to odds. I do have two odds to a single even, and the Turing Machine approves of that. So that means that there should be less even than odds. So let's go ahead and type that up in our notes for section C. And we'll say that there should be less even than odds. Well, I'm glad I tested that, because that means that both triangle and circle must actually be odd, since we already have our single even in square. So let's go ahead and cross out all the evens in triangle and circle. So now we know for sure that we can't have a 6 in triangle or in the sum of triangle and square, because you would require either 2 odds or 2 evens, and we are dealing with a mixture among triangle and square. It can only be either less than 6 or greater than 6. And so I think, now it may be a good idea to go ahead and test criteria card. Well, let's see. It is a 50-50. Let's see. It is a 50-50. Maybe we can wait until the second round. I'm trying to think of, normally we often can deduce criteria card F, the ordering, and in this case I don't see the obvious criteria cards that would lead us to that. We are dealing with 2 odds. The question is, are those odds paired up? That would also be another 50-50. We know that it can't be a triple number. So either there is a pair of odds or there isn't. And so the question is, let's see. Well, if we have, actually, I think if we have a pair, that might be our indication. Let's see, how would that work? If we ever have a pair of digits, whether they're consecutive or separated by that middle digit, we would know that they would have no order. So I think we can actually say that we can deduce that the solution should have no pairs. Because if you had a pair, whether, again, here in this example, it's separated, the ones are separated by the 3, or if they were consecutive, that would be no order, making this irrelevant. So I do believe we can deduce that there should be no order. So that is E. So I'm going to type it up as we're going to deduce that the solution has no pairs. Because again, if you did have a pair, then it would exhibit no order, making this card irrelevant. So there we go, has no pairs. So that saves us from that. What else can we say? Can we also make the other argument that if it's descending, it would have no pairs, right? Because remember, ascending and descending, I should say, they're either ever increasing or ever decreasing, never paired up. So I think you can even say that that if it's ascending or descending, it would mean that there are no pairs, making this card irrelevant. So I'm mistaken. I guess there is that interaction. So I think we can even deduce that the solution should have no order because of that argument. Yeah, if it's ascending, there are no pairs. If it's descending, there are no pairs. So yeah, I think we can safely deduce that the solution has no order. Wow, amazing how we can come to those conclusions. So we're looking for all distinct digits. Again, they can't be a single digit repeated because we do have a mixture of even and odds, and they have no order. Well, I guess it boils down to maybe criteria card D. Let's see if the sum should be smaller or larger than 6. Yeah, no pairs. So yeah, let's go ahead and test criteria card D. Okay, so it does agree with my proposal where the first two digits add up. So 3 plus 1 is 4. And since 4 is less than 6, the Turing machine approves of that. So yeah, the sum of the first two digits should be less than 6. So let's go ahead and type that up in our notes. And we'll say that triangle plus square should be less than 6. So let's go ahead and see what can we conclude. Well, I think we can conclude that triangle cannot be a 5 because 5 plus even the smallest of 2 is already greater than 6. But square 4 is okay. That is, if you added, well, you could add it to 1, maybe not 3. That looks good. Okay, well, this was a very productive first round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. Well, it looks like the only thing that we really need to establish is criteria card A. We've already deduced the last 2, so there's no need to test for that. And we just need to figure out what triangle should be. Should it be less than 3 or equal to 3? Now notice the other thing is that there is no mention of circle among our 6 criteria cards. So that circle value will have to be forced into a particular odd value. So we do know that it has to be odd, and more than likely in combination with criteria card E and F, they're not going to be paired up, and they should have a no order. So let's see, is it worth listing out possibilities? Let's see. Let's see, if we say triangle is 1, then that would force square to be 4 because 1, 2, 3, and 5 would all be increasing, going against our deduction that there should be no order. So it looks like, let's go ahead and type some of these possibilities out. And so if triangle is to be a 1, it has to be square 4, otherwise it'd be an increasing solution. So let's go ahead and say it's going to be 1, 4, and because there's no order, the only possibility is the 3. The 1 is disqualified because you would have duplicates. So that's the only possibility for triangle 1. What about if triangle were 3? That would be 3, 2, 5. And then 3, 4, 1. 3, 4, 1. Those seem to be the only 3 possibilities. Let's see, we do have, let's see, would the last 2 be ambiguous? Is there a way to distinguish? Actually 3, 4, 1 does not qualify since that sum is greater than 6. So I should not have even written it, so I'll just cross it out. So yeah, so it seems like it's a bit of a 50-50, either that triangle value is 1 or 3. And let's see, anything else? Yeah, it kind of forces everything else to play out, the square value and the circle value. So the question is, what sort of distinguishes them? And if we look back at our criteria cards, are there any additional clues? Why did the puzzle makers choose these cards? Yeah, I'm not sure if we can. It's fair to ask those questions, but I don't know if there's a way to really kind of reverse engineer what it is. Well, I guess I'll just, let's see. I think I'll choose 1, 4, 3, and we'll just go from there. Okay, so again, just to double check, that middle digit is even, yes. There are more odds, that's true. The sum is less than 6. Yeah, there are no pairs. Our deductions are no pairs and no order, and that's true. All right, and we're only going to test criteria card A. So let's see. Okay, so it is not true that, again, my choice for triangle is 1. 1 is less than 3. But since the Turing machine does not agree with that, it is not the case that triangle should be less than 3. So what I'm going to type up is that I'm going to deduce, based on our answers thus far, I'm going to write it up as that I'm going to deduce that triangle should be equal to 3. So let's go ahead and type that up. So I'm going to say, that's true, I was going to say deduce that triangle is equal to 3. And so that means that 1, 4, 3 is not correct. It looks like our solution should be 3, 2, 5. So let's go ahead and cross out the 1 in triangle. And that forces square to be 2, so that the sum should be less than 6. And because of no duplication and no order, circle cannot be a 1, nor can it be a 3. So yeah, it looks like our solution is 3, 2, 5. So let's go type it up and we will verify. Okay. Well, let's see if these deductions paid off. So 3, 2, 5. Fantastic. Well, how do we do versus a Turing machine? Well, it is a 6 criteria card puzzle, but we only did 4 tests. Amazing. So we did B, C, D in the first round and A in the second round, and we deduced outright E and F. So let's go ahead and type that up. So B, C, D, B was incorrect, C and D were both correct, and A was incorrect. So, okay, fantastic. So we beat the Turing machine by 2 questions. I will admit, I think I do recall maybe a few other puzzles where I've gotten the solution in 4 questions. It just happened to play out, luckily based on the criteria cards I chose or the proposals. But I think this might be the first time, though, where I made this connection outright. I think the other times, again, it was just sort of obvious, I guess maybe because of ambiguous solutions. But how about you? How did you solve it? What criteria cards did you pick, and did you discover anything interesting that you'd like to share? Please add those thoughts to the comments. If you did like the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.